Hello there. I'd like to talk about chemistry today, the basics of chemistry, like elements and stuff like that. So I'd like to talk about chemistry today, if that's all right. Okay then. Right. The nucleus is found at the centre of the atom and contains neutrons and protons. Protons have a positive charge and a mass of 1. Neutrons have no charge and have a mass of 1. Electrons have a negative charge and a negligible mass. In all neutral atoms, the number of protons is equal to the number of electrons. So the protons and the electrons have the same number of the protons have the same number. An example is sodium, actually. Sodium has 11 in a neutral atom. Sodium has 11 protons and 11 electrons. So I just thought I'd say that to you. The mass number is the number of protons added to the number of neutrons. The atomic number is the number of protons. So sodium has an atomic number of 11. It has 11 protons, and as I've already mentioned, neutral atoms have the same number of electrons as they do protons. So I thought I'd just mention that to you. Now, in the nucleus, it's in the middle of the atom, and it contains protons and neutrons. And the nucleus has an overall positive charge, because protons are positively charged, while neutrons have no charge. So I just thought I'd mention that. Atoms have no overall charge. They are neutral. They must therefore contain equal numbers of protons and electrons. The number of protons an atom has in its nucleus is called the proton number, or the atomic number. And the number of protons and the number of neutrons an atom has in its nucleus is called the nucleon number, or the atomic mass. So I just thought I'd mention that to you. Yeah, so an atom has a central core called the nucleus, which contains nearly all the mass of the atom. Within the nucleus are two types of particles, protons and neutrons. Protons have a relative atomic mass of 1 and carry a charge of +1. Neutrons have a relative atomic mass of 1 but carry no charge. Orbiting the nucleus at very high speeds are extremely small particles called electrons. Right, so I thought I'd just mention that. Ionic bonding involves electron transfer between metals and non-metals. Both metals and non-metals try to achieve complete outer electron shells. Metals lose electrons from their outer shells and form positive ions. This is an example of oxidation. Non-metals gain electrons into their outer shells and form negative ions. This is an example of reduction. The ions are held together, ions, I-O-N-S, are held together by strong electrostatic forces. So when atoms form ions, they try to complete their outer electron shell. For metals to do this, it is easier to lose electrons than to gain them. For non-metals, it is easier to gain electrons than to lose them. So I just thought I'd mention that. So if and when a sodium atom loses an electron to form an ion, it's a 1+ charge. The sodium ion equals 1+. So if and when a chlorine atom gains an electron to form an ion, the charge, what is the charge on a chloride ion? It's 1-. And what is the charge on a sodium ion? It's 1+. So that's right. So if a sodium atom loses an electron to form an ion, what is the charge on a sodium ion? And that is 1+. Right, and also I'd like to say oxidation is any process where electrons are lost, and reduction is any process where electrons are gained. So I thought. So yes, if we just recap a bit here, the mass number of an atom equals the number of protons plus neutrons in the nucleus. The atomic number of an atom equals the number of protons in the nucleus. So the mass number is the atomic number, and that's right, the number of neutrons in the nucleus, that's right, so it's combined with protons and neutrons. And that's the mass number. Thought I'd just mention that. Electrons have a tiny negative electrical charge. This means they are attracted to positive electrical charges and pushed away by negative charges. So yes, electrons remain close to the nucleus because the protons in the nucleus have a positive charge that equals the negative charge of the electrons. And I'd just like to mention here that the electrons are arranged in shells at different distances around the nucleus. Each shell can hold a particular number of electrons. So the first shell can hold up to 2, the second up to 8, the third up to 18, the fourth up to 32, the fifth about 50, and the sixth about 72. So I thought I'd just give you that information. So as I've already said, if we talk about atoms, at their centre is a nucleus consisting of protons, which have a positive electric charge, and neutrons, which are uncharged. Around the nucleus are the negatively charged electrons. So yes, and it is the electrons that gives a substance most of its physical and chemical properties. Right, and if an atom loses an electron, it becomes a positive ion, which is a cation, C-A-T-I-O-N. If an electron is gained, an atom becomes a negative ion, or an anion, A-N-I-O-N. So, ions of opposite charges will attract and join together in a type of bonding known as ionic bonding. And in covalent bonding, the atoms bond by sharing their electrons in what become molecular orbitals. So yes, I just thought I'd mention that. And if I talk about electrons now, well, atoms are neutral, so they must also have a positive part containing protons. And the electrons move around the nucleus like the planets around the sun. That is not strictly true. There is a little bit of truth in it, but it's not strictly true. If I just... Because the... electrons are sort of packets of energy travelling around the nuclei of atoms. It is impossible to pinpoint the exact location of an electron. An electron does not circle a nucleus as a planet circles the sun. Instead, it is more accurate to think of an electron wrapping around a nucleus like a cloud. But some literature, having said all this, some literature does state that electrons move around the nucleus like the planets around the sun. So, maybe that's more of a layman's type term about orbiting, about the move around the nucleus like the planets around the sun. So when I say electrons move around the nucleus like the planets around the sun, that's probably more of a there's a little bit of truth in it, but that other definition is probably has a bit more truth in it. That sometimes in science there are some contradictions. It's not all black and white actually. So I just thought I'd mention that. There's quite a lot to take in there. Ionic bonding occurs between metals and non-metals. So that's true. Protons and neutrons are also called nucleons, as they reside in the nucleus of the atom, should I say. atoms are what every substance is made of. They are the smallest bit of any substance, yet atoms are largely composed of empty space and dotted with even tinier clouds of energy called subatomic particles. Subatomic particles. And I've mentioned the electrons, the protons, and the neutrons. And I think there are some more. But I'm just starting on that. Right. So what is the nucleus? Well, most of an atom is empty space, but at its centre is a tiny area called the nucleus. This contains two kinds of nuclear particle: neutrons with no electrical charge and protons with a positive electrical charge. So I just thought I'd mention that to you. There's quite a lot to take in here. So every atom has a dense core, the nucleus, made up of two kinds of particle, protons and neutrons. Protons have a positive electrical charge and neutrons have none. Now, if the atom were the size of a sports arena, its nucleus would be the size of a pea. So, just try to give you some sort of example, some basic example of what the size of the atom would be like. Smaller negatively charged particles called electrons whiz around the nucleus. I could go into it a bit with more detail. Protons and neutrons are made from different combinations of even smaller particles called quarks. Q-U-A-R-K-S. And so atoms can be split, but are usually held together by the electrical attraction between positive protons and negative electrons, and the forces that hold the nucleus together. And if I talk about another thing today, isotopes. Now, isotopes are of an element have the same number of protons, but a different number of neutrons. So isotopes have the same atomic mass. Same atomic number. So isotopes have the same atomic number, but a different mass number. So everything. So the isotopes have the same number of electrons and protons as your atoms on the periodic table, but they do have a different neutron number. So so they have different neutrons, but the same amount of protons and electrons. So if I recap, isotopes of an element have the same number of protons but a different and electrons, but a different number of neutrons. So if I just give you an example, chlorine, for example, on the periodic table, chlorine has 17 protons and electrons. And that's right, 17 and 18 neutrons. So and they have a mass number, I think, of 35. But the isotope of chlorine is which isn't on the periodic table is 17. So it has 17 of protons, 17 protons and electrons, like the other one I mentioned, but 20 neutrons as opposed to 18, and its mass number is 37. So I just thought I'd say that. And actually, carbon has two. The one on the periodic table is carbon 12. So that's 6 electrons, 6 protons, and 6 neutrons. So 6. But carbon 13 has 6 electrons, 6 protons, the same as carbon 12 in that respect, and 7 neutrons. And if I mention carbon 14, 6 electrons, 6 protons, and 8 neutrons. So carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, carbon 14 has 8 neutrons. And carbon 14 is radioactive, so it's dangerous. It's a dangerous one. And 12 and 13 are stable, and 14 is unstable, and it's radioactive. Because gamma rays is the product of radioactive atoms. So it's the product of radioactive atoms, depending upon the ratio of neutrons to protons within its nucleus. An isotope of a particular element may be stable or unstable. So yes, yeah. So if I just repeat myself, gamma rays is the product of radioactive atoms, depending upon the ratio of neutrons to protons within its nucleus. An isotope of a particular element may be stable or unstable. Now, if I look at carbon 12 and 13 are stable, and carbon 14 is unstable, and I think the more neutrons an isotope has, the more unstable it is. But don't quote me on that. But I think there's some truth in that. So yeah, obviously, I think the more neutrons it has, the more unstable it is. I think anyway. So I just thought I'd mention that. And yes, and oxygen actually. Oxygen 16 is the one on your periodic table. And it has 8 protons, 8 electrons, and 8 neutrons. Now the two isotopes are oxygen 17 and oxygen 18. So they both have the same number of protons and electrons, and that's 8. But they have 10 neutrons. So oxygen 18 has 10 neutrons, oxygen 17 has 9 neutrons, and oxygen 16 has 8 neutrons. So I just thought I'd mention that to you, yeah. So, yeah, isotopes are atoms of the same element containing the same number of protons and electrons, but different numbers of neutrons. So I just thought I'd reiterate that again. Yeah, so and before I leave you today, I'm going to just show you something here. Now, I've put here the neutrons in the nucleus are the neutrons and the protons, and that's plus. That's plus. So I just thought I'd mention that it has an overall plus, doesn't it? Because the protons are a plus, as I've already mentioned. And these energy levels here, I've got some energy levels here. That one, I've got 5 there, if you don't mind. I've just written 5. As you can see, 5 energy levels. And as I mentioned, each one can hold up to a certain amount, and I have mentioned that to you. Yes, I did mention it. Yeah. So I just thought I'd show you that. And nitrogen, and I'm going to talk about ions now, actually. So the atom nitrogen is 2,5. Configuration is 2,5. The ion is 2,8. So it has 10 electrons. So yeah, the nitrogen is 2,5. So in the atom, it has 7 electrons, 2,5. That's the first energy level is 2. The second one is 5, the second energy level. And the iron has 10 electrons, 2,8 configuration. And it's... yeah, so that's right. So the nitrogen has actually gained 3 electrons. So that's why it's a -3 charge on it. So that's right. So it's gained. So it has a 3- charge. This nitrogen atom, the iron has a 3- charge, and the nitrogen atom has actually gained 3 electrons. So that's how it works. So when it's gaining them, you get a -3 there. The phosphorus here, the phosphorus atom is configuration. The atom is 285, and the iron is 288. So again, it's the same. It has a it works the same as the nitrogen. So I'll just put here. So that's a -3. It's -3 like the nitrogen. Now I've got the aluminium atom here, which is 283. These are the electrons I'm talking about. I'm just not talking about protons or neutrons. I'm not talking about protons or neutrons. I'm just talking about electrons here, and that's a 283. Aluminium is 283, and obviously 2 in the first energy level is 2. The second one is 8, and the third one is 3. So if I was to do that, if I had footballs, like the electrons, I think of them a bit like footballs. I'd put that one would be 2 if we're looking at the aluminium. The second one would be 8. Yeah, as we go round it, the second one would be 8, and the third one would be 3. So I just thought I'd mention that. Yeah, there's quite a lot to take in, I know, but but the aluminium loses its third energy level, because 2 is the first energy level, 8 is the second one, and 3 is the third one. Now, the aluminium loses the third energy level, and it's so the iron has 10 electrons, and the atom has 13, and the iron of the aluminium ion has 10 electrons, and it's got a +3 there. So when it loses the electrons, it's actually got a plus, and when it gains, it's got a minus. For the non-metals are the ones that gain electrons, and they have a minus charge, and the metals lose electrons and have a plus charge. So yeah, oxygen here. I've got oxygen. That's 2,6. The atom is 2,6 with its energy level in the atom, and the iron is 2,8. So it's actually got, it's gained 2 electrons and it's got a -2 charge. And then I've got chlorine here is the atom 287. So the iron then is 288. So the iron gains 1 electron and has a 1- charge. And I think actually the iron is chloride, but I'll talk about that next time about chloride. But that actually, the chlorine becomes chloride ion. It's not, so that's how it works. Because the halogens have different names for their ions, but I'll talk about that at a later date, if you like, if that's all right. And then lithium is 2,1. That's the atom is 2,1, and it loses its second energy level to become 2, and it's got a +1 charge. So I thought I'd mention that. And the atom sodium is 281, and the iron is 28, and it loses its third energy level, and it's a +1. Right. So I just thought I'd mention that. The atom potassium is 2881, and the iron loses the fourth energy level, and it's 288. 8, and it has a charge of +1. So it's 19 electrons in its atom, and 18 in the iron form. It has 18. So I just thought I'd mention that. So it's lost this. Potassium has actually lost the iron has lost an electron, and it has a +1 charge, and it's lost its fourth energy level, the potassium there. And the sodium has lost its third energy level when it becomes an ion. Yes, it's quite tricky stuff really, but I hope I'm simplifying it for you anyway. And then of course, I've got magnesium here, and that's its electrons in the atom are 282, and you'd have 2 there, 8 there, and 2 there, like little footballs going, or if that's the sun and it's orbiting the like planets are orbiting the sun, isn't it? The electrons, and then the electrons are like the planets, and the neutrons and protons in the nucleus are like the sun, but that was more of like a layman's sort of term. But as I've already mentioned earlier on today, so yeah, the magnesium atom is 282, the configuration, and then when it becomes an ion, it loses. So it's gone from 12 to down to 10, and it has a +2 charge. And the calcium is its configuration for calcium is 2882. And then it loses the fourth energy level, so it's 288. So it's 18. The iron has 18 as opposed to 20 there. And then you've got bromine there, bromide should I say, because it's another halogen, and that's 28187. So it's got 4 energy levels, 28187, and the iron it becomes 2, 8, 18, 8. So it gains an electron with a 1- charge, that the halogen there, the bromide. So it's from a bromine atom to a bromide ion. Anyway, I thought just today I've just tried to mention some of the basics to you. Some of it's been quite tricky, I know. Anyway, I hope it's sort of made things a bit clearer for you, today's lesson. Anyway, thank you very much. Thank you. Thanks.